Hello again and welcome back. So this is what we have currently. Let me change the real-time playback option, and now this is what we have. Everything is falling. And I think the most important thing right now is to get the collision working properly. So let's do that. I'm going to go back here to the sub level, and collision with smoke works should be treated the same way we learned in week 6, because in reality what we're doing is we're creating volumes collision in the flip fluid, and we have to give a perfect volume representation of the of that guy of the of our mesh. So what we're going to do is we're going to create a null, and we're going to say this is the output statue out statue. I'm gonna give it a blue color, and then we need also a volume representation. Okay, I'm not going to use this guy here because it's a volume representation of a different mesh, and I'm gonna create a new one. So I'm gonna put down a VDB from polygons, and I'm gonna use this this new geometry here, and we're going to convert that into a volume, and I'm going to set it to 0.2. And if you guys remember, we previously we always use the SDF for the collision fields, and that's what Houdini wants. It doesn't want just a volume fog like this. It needs the SDF to collide with, because that's how Houdini knows whether a particle went inside the mesh or not. It uses the SDF to figure that out. I'm gonna copy this and call this out statue collision. Let's call it VDB collision to make sure. And I'm gonna dive back inside, and we're going to create a static object and point to the geometry out statue. And this is exactly the same as the flip. I'm gonna put down a merge and merge this with the ground. And let's make sure the ground is not floating that high. It's good. And for the static, we're going to set our own volume. So I'm going to change this to volume sample, and then specify the volume that we just created. And if I view the collision now, we have a perfect volume representation that the flip can collide with. I'm going to uncheck display geometry because I don't want that. And I'm going to hit play. And now we should see a perfect collision between the sorry, I said the flip, between the smoke and the geometry. Cool. Okay, so what we're going to do next is we're going to make this more interesting. But before I start creating forces to randomize this, I want to do something where we add extra velocity to the source. Instead of having this, no emission, no velocity coming from the volume, I want to give it a custom velocity. And this is why I used the normals. So we can simply take these normals and convert them to a velocity field. And the way to do that is if we come here under this velocity volume, it tells us how to it asks us how we're going to create this volume field. And right now it's set to stamp points, and it's looking up for a point in the value called an attribute on the points called V, and we don't have that, so we're simply going to use N for now. And you can see right away that by doing that, it's displaying these things here, and that's the display method used for the val. So I can uncheck this guy here, and you can see we have normals, we have velocity pointing in this direction, and there is this curl section here that we can add to add more randomization to the field. But for now, I'm not gonna do that. I'm gonna leave it as it is, and I'm gonna dive back inside, and I'm going to hit play. And you can see it's pushing things in along the normal direction, but I don't want that exact same thing. I don't want that. I want the velocity to follow along the surface a little bit, but also push. I want the velocity to push along the surface flow, instead of just pushing outward, I want it to push along the surface flow, so we can have something falling from here all the way through the hand, or something from the head that travels through, or something from the chest that follows through the surface. And so the way I'm going to do that, I'm going to put down a point vault, and we need to create these vectors. And for that, we're going to use the cross product. So let me display the normals. We're going to use the normals to display our effect. And I'm going to put down a cross product and plug that in here. And for this one, we're going to set it to point to the y-axis. And now we have something that follows the surface, but it's rotating along the surface. So let me reduce the points so we can see it better. If we look at it from the top, you can see it's creating this circular motion here, but I don't want that. I want something that follows along the surface. And the way we're going to do that is we're going to do another cross product between this result and the normals. And now if I connect this guy, you can see we have the normals following the surface. And let me negate this so we have a better representation. You can see we have a better representation of the surface, and let's create more points. You can see we have this vector here that travels somewhat along the surface. Okay, but I don't want exactly this vector here. I want something that I can control its orientation a little bit. So what I'm going to do is I'm going to put down a mix node, and I'm going to mix the this result with the new result. So both of them, both vectors. This guy that is swirling this way, and then this guy that is following the surface. I want to mix those. So now we have something that goes down as well as it follows the surface as well as it's rotating around it, and this will create a more interesting effect. And you can see we can toggle this, we can blend between them. And I'm going to set this to 0.418, and now I am going to connect that instead. And let me actually plug this into velocity because I don't want it to be the normals. I don't need the normals anymore. And then here, instead of stamping N, we're going to stamp V. And you can see we have a velocity that represents the flow of the surface along with the small amount that will cause it to swirl. Okay, and we can mix all of this with some curl noise, but for now I'm not going to do that. But you guys can explore doing that. We can add more randomization to the way the vectors are going to point. Cool. So let's dive back inside and let's hit play now. And we should see the volume behaving a little bit better. And see this these points here? That's a OpenGL issue, and it's keeping those in the OpenGL memory for some reason. So if I create a new one, that fixes everything. It resets the viewport. So I'm gonna hit play, and now we have velocity pushing randomly, pushing the field, the smoke along the surface as well as revolving it, and that helps to make something more interesting. But you guys get the idea of how we can create velocity and push that into the smoke. We have also the scale here. We can scale the velocity, and that will cause it to increase. You can see it's creating some really nice effect over here where it's pushing and pushing the points, the smoke, and because there is a collision mesh, it's colliding and sliding along it. So that's really nice. You can see it did this swirl here. That's very interesting. I'm gonna hide the ground because it's not helping me view the result. And you can see how it swirls at the beginning, and that's very interesting effect. Cool. So let's see. We're going to create the extra forces to make this more interesting, and we're going to do that in the next video. Thanks for watching, and see you in the next one.